Okay, in this video we are going to solve exercises on the previous lecture on sampling distributions and the central limit theorem. So before I start, what I want you to do right now is from this YouTube video, go below it, you'll find the PDF file of this lecture. Please open it. Okay, and then when you open it, either print it or open it in a PDF annotator, so a PDF that you can write on, and then you can write with me. Okay, so please do this now, and once you have the PDF, you continue watching the video. Okay, so as you know, we are solving exercises on the previous lecture with the same title, Sampling Distributions and the Central Limit Theorem. And believe it or not, this page here that you can see summarizes everything that we did in the previous lecture. So first it shows you the unbiased property of the sample mean, which is exactly this thing here. And this thing, you read it as the mean of the sample means is equal to the population mean. Okay? And the second one is the standard error of the mean. And this is the standard deviation of the sample means. So the standard deviation of the sample means equals the standard deviation of the population divided by the sample size, the square root of the sample size. Okay, these are the two formulas that you need to remember. So let's color this also. These two are important, and then the central limit theorem. If you remember, it was this one, number one, but we put number two because it is related somehow to the central limit theorem, and it's nice to see the two together in one graph. So, or one illustration. So it says that if you have any population distribution with mean mu and standard deviation sigma, and the shape doesn't matter, it could be anything, then if you take the distribution of sample means, if you remember we called this x bar, and the sample size is bigger than or equal to 30, then the nice thing is that the sampling distribution of sample means, or the distribution of sample means, will be approximately a normal distribution. But this normal distribution will not have the exact standard deviation as the one here. So you see, it actually will have the same mu. Mu doesn't change. The one for the population distribution that you started with is going to be also the mean of the sample means. This is a very nice fact. But the standard deviation will not be the same. It will not be sigma, but what it will be is sigma divided by the square root of the sample size. Okay, good to know this. And in the special case, I mean, it's not a special case of the central limit theorem, but this is special, I mean that you start already with a normal distribution for the population. Then the distribution of sample means exactly as what we did in the previous one, but here it's for any n. So n doesn't have to be bigger than or equal to 30. It can be anything. Any n, you will get a normal distribution. And if you started with an exactly normal, you will get an exactly normal distribution here for the sample means. And the mean is the same as the population mean, and standard deviation also the same as the previous formula that you see here. Okay, so it's very nice to know. But remember that we said that if you have a distribution, let's say that is approximately normal, like kind of symmetric, but little bit away from normal, little bit, then for something that is like this, fairly symmetric, you can say it's kind of symmetric around the mean, then you can apply the this thing here, but the n here could be, let's say, bigger than or equal to 9. And if it's fairly symmetric, like less close to a normal distribution that what you see here, then maybe you need n bigger than or equal to 15. Okay? But if you start with an exactly normal, like what this is saying, if you start with exactly normal distribution, then the distribution of sample means will be also exactly normal, with mean mu and standard deviation sigma divided by square root of n. Okay, good to remember this. This is like a quick review of what we've done in the previous lecture. If you forgot any of this, or if you want to see examples on this, please watch the previous video before solving the questions here. So now let's go to the exercises. If you remember, in the previous lecture we had 4 exercises. 1, 2, 3, 4. I have added 2 more exercises, 5 and 6, in order to make it better. So you have 2 extra questions that will make you prepare more for quizzes or homeworks. Okay, but I'm not going to solve all of them in this lecture. In this lecture, I'm going to choose 4 of them to solve. So let me choose 4 now. Let's say from the questions that I received from some of you, you asked me about question number 1. Not all of the parts, but I will solve it all. I will also solve question number 2 because I got some emails and messages about it. I will solve also number 4 and number 6. The reason is, I will tell you now. Problems 1, 2, and 3 are kind of similar to each other's. So I solved 2 of them, 1 and 2, and I'll leave 3 for you. And this way you can interact more with your teacher, okay, whoever is teaching you. So this, take it as your homework that you will do and send to your professor, the answer to it. And number 5. Okay, so this also is a homework for you, because 4, 5, and 6 are of the same type. So I will solve 4 and 6 and you do 5. Okay, now we agreed on this, so let's start. We're going to solve problem number 1. So let's read it together. It says, the length of time a battery lasts in a laptop is normally distributed. So we know that it's normally distributed. This is very good to know from the beginning. Okay, so I'll put a happy face here. Because when you start with a normal distribution, remember, you don't have to make sure that your n is bigger than or equal to 30. This is, you can do it for any n. If you take any sample of size n, then it's fine. The distribution of sample means will also be a normal distribution. So let's go back and see. That's why we're happy here. And now, what is normally distributed? What is normally distributed actually is the length of time a battery lasts in a laptop. So this here is our random variable that we will call x. So let x, so here from the beginning, let x be the length of time, laptop battery lasts. Laptop battery lasts. And we know that it's normally distributed. So you can say here x follows a normal distribution with mean mu and standard deviation sigma that they will give us. So now mu is, it says here, with a mean of 240 minutes. So mu is 240 minutes. And the standard deviation of 15 minutes. So you write sigma, the population standard deviation, is 15 minutes. This is also telling you that the x, the random variable x, is given in minutes, of course. Okay, so let's see what they want us to do. So the first question is, what is the probability that a selected battery will last more than 250 minutes? Notice here that we didn't take a sample. It's just one battery. And they want us to find what is the probability that the battery or the length of life of time it lasts, so probability of X is more than 250 minutes. This is the question, is find this. Okay, here there is no sample, so there is no need to use the distribution of sample means or anything like that. Okay, so you must read the question. Here we just selected one battery. So there is, you don't have to apply anything. Just apply what we know about normal distributions in general. Okay, so we will go to our online calculator, and here we have to get, of course, we are given a value 250, and we need to find an area, the probability. Remember, the probability is an area. So we will do area from a value, and then we put the mean. Our mean is 240, standard deviation is 15, so 15, and we want the probability that it will last more than 250, so above. You will put above 250 and calculate. So write the answer here. You can see it's I also want you to always see the picture. Okay, once you solve it, look at the picture also. So here you'll have 0.2525. So the probability is about is exactly 25.25% that the selected battery will last more than 250 minutes. Notice that you can also put or equal, because the probability that X is a random variable is an exactly one value is 0. So it doesn't matter whether you put it or not. Okay, so but since they said more than, they didn't say more than or equal to, so we will keep it as a strict bigger. All right, so now let's see the second question. What is the probability that the mean time of nine randomly selected batteries is more than 250 minutes? So they are asking us the same question, but now we have n, the number of batteries, or the sample size is 9. Notice that it's 9, but the distribution of X, the population distribution, is normal already, so it doesn't matter what n is. N can be anything. We don't have to be more than 30 in this case. So n is 9, and so let's immediately after you find n, find mu, the mean of the sample means, which is the same as the population mean, as we know, and the population mean is here, 240 minutes. So this is nice, and the standard deviation of the sample means, this sample, the 9, is equal to the population mean, the population standard deviation divided by the square root of the sample size. And so in this case, our sigma is 15, so we'll do 15 divided by radical, n is 9. So it's 15 over, radical 9 is 3, so 15 over 3 is 5. This is 5 minutes. Okay, so 5. So now all what you have to do, let's highlight so you can follow easier. So this is sigma x bar, and this is mu x bar. Now that you have the mean and standard deviation of a normal distribution, you can use the calculator. So now the mean is the same, because the mean of the sample means is the same as the population mean, but the standard deviation will be different. It's 15 over 3, so we have to change it to make it 5 now. And it's the same question, above 250. So here I just will write, this is what they're asking. The probability that the mean time, so the probability of the sample mean bigger than 250 is equal to, and let's calculate. This will be 0.0228, which is this will be as a percentage, it will be 2.28%. So this is the answer here. The next question is, what's the probability that the mean time of now 36 randomly selected batteries is more than 250 minutes? So now our n is 36, and we are doing, here again, it's the probability that the mean of those 36 batteries will be more than 250 minutes, the mean lifetime. Meaning that how long it takes until it drains the battery. Okay, so n is 36, so mu x bar, again, it's the same as mu, so it's 240, and the standard deviation of sample means is standard deviation over square root of the sample size. Standard deviation of the population from above, you'll get 15, divided by now square root of sample size 36, that's what's given. So this will be 15 over, radical 36 is 6, and 15 over 6 is 2.5. You can do it on your calculator. So this is 2.5 minutes. And now you have, let's choose another color. You have the mean and the standard deviation of the sample mean. Okay, and so the distribution of sample means, and so you can use the calculator here. The mean is still 240. The standard deviation now is, what was it? Let's see again. It was 2.5. You see here, now your standard deviation is 2.5. And you also want to do above 250. This is what they're asking here. All the questions are the same, but they're just changing the sample size. And so calculate this, what did I put? The probability, the mean. So above, let's do it again. So the probability that it's above 250 is, yeah, so it's 0 in this case. Yeah, we can see this actually. Because if you look at the graph, if the mean is at 240 and then the standard deviation is 2.5, so you see if you take 2.5 plus 2.5 plus 2.5, and of course you can subtract them, but if you go 3 standard deviations away from the mean, you will be at 247.5. And so to get to 250 is very far from the mean, to the point that the probability is almost 0. So I would say this is not exactly 0, but to at least 4 digits it's 0. So you can put the answer as 0. Now let's go to the next one. Now it's exactly the same question, but you have 81 batteries. So n here is 81, and mu x bar is the same as mu, which is, I think it was 240, and the standard deviation of the sample means is the standard deviation of the population divided by the square root of the sample size. So this is, the standard deviation was 15, remember? So we put 15 over radical, now 81. So this will be 15 over 9, which if you do on your calculator, you'll find it's 1.666 forever, so 667 approximately. So let's just put here approximately. So now this is our mean and this is our standard deviation. So all what we have to do is to go to the calculator and put them there. So 240 is already there, so I'll put 1.667 for the standard deviation, 1.667. And again, above 250. So calculate. This is 0 again. So the probability that x bar is bigger than 250, of course, you should expect it to be 0. It's not exactly 0 again. It's very close to 0, that at least the first 4 digits are 0 in it, or the first 5 digits even are 0. Okay, and that's that you can see it easily. In the graph, you don't even see it. It's 250. Where would it be? Look, the graph here, 245 is 3 standard deviations away from the mean, and so 250 will be in a place where it doesn't have really any area. So the probability is 0. And the last question is, if the population of times is now not normally distributed, so if from the beginning we didn't have the happy face, so it was not normally distributed, then the question is, which, if any, of the questions above can you answer and justify your answer? Well, you can see that when the sample size was 9, you cannot solve it, because if it's not normal, then you need more than 30. So in this case, what you can solve are C and D. Those for the sampling distribution of sample means. This you can solve. But so you can say here, I can solve C and D. So can solve C and D, but not B. Make sure that you understand why. Because, okay, I will tell you, because in both cases n is bigger than or equal to 30, so central limit theorem can be used. But in B, remember the n was 9, so we need the distribution to be normal in order for the distribution of sample means to be normal. So, okay, so this one you cannot solve it if not normal. Okay, this should make you understand the central limit theorem better. Okay, you always can refer to this picture here and it will summarize everything from the previous lecture for you. I suggest you keep this paper with you when you're solving the exercises, because it has the two important formulas for the mean and standard deviation of the sample means, and it reminds you of the central limit theorem and of the nice fact about when you start with a normal population distribution. Okay, so now we're done with problem 1. Let's go to problem 2. So this one, you will find a similar problem to it in the lecture that came before this. So it says the amount of time a bank teller spends with each customer has a population mean of 3.1 minutes. So population mean of 3.1 minutes and a standard deviation of 4 minutes. So it didn't tell us anything about what the distribution looks like. So we cannot assume it's normal here. You cannot read normal anywhere. Okay, make sure that you understand this. Now, this amount of time a bank teller spends with each customer, this will be our random variable x. So is it okay? I will just say x equals, and then you remember that we defined it to be this. Okay, instead of me having to write all of it, so just remember that we defined x to be the amount of time a bank teller spends with each customer. And it is given in minutes. So because our population mean is 3.1 minutes and standard deviation is 0.4 minutes. But for mean and standard deviation, I will write them down. So the mean here is 3.10 minutes and the standard deviation is 0.40 minutes. Okay, so now the question is, what is the sampling distribution of the mean? First we need to read, if you select a random sample of 16 customers, so now your n is 16. Notice that it's less than 30. So we cannot answer this question. So what is the sampling distribution of the mean? You can say we can't tell. Okay, why we can't tell? Because we need, because n is relatively small, so we need our original population distribution, so the distribution of the x that you see here, it needs to be normal or fairly normal, like very approximately normal or fairly symmetric. And so you can say here, but if x is normal, it's okay, 16 is fine, no need to worry. So you can say, but if x is normal or approximately normal, so fairly symmetric, let's do it like maybe fairly symmetric, approximately normal is still better than fairly symmetric. So you can say here, or fairly symmetric. You would look at it and see that it's fairly symmetric. If it is approximately normal, fairly symmetric, or no, of course, if it's normal, there is nothing. You can use any n, but approximately normal, it's okay. You can still use n equals 16 to be able to apply the central limit theorem. This one holds. So we can say, what is the sampling distribution of the mean? You will say, if it was normal, this will be also normal. And if it is approximately normal or fairly symmetric, then it will be approximately normal, the sampling distribution of sample means. This is what the central limit theorem says. Okay, this is what the second part that we had after the central limit theorem. So here, I mean this one here. And I explained to you at the beginning of the video, so go back and you will see when I talked about this n, when I said that if you have approximately normal, not normal precisely, but very close to being normal, then the n here, not any n, but you can take n bigger than or equal to 16, that's fine. It will be, the result will hold, that the distribution of sample means is going to be approximately normal. Okay, so I'm spending some time on this because I think that it's important. Now, what is, let's say, I will solve D first. What assumptions must you make in order to solve A and B? So the assumptions are, we assume that x is normal, that our random variable x is normal or at least approximately normal, so that we can use a small sample size. Okay, if you want to avoid headaches, always take sample size bigger than or equal to 30. Okay, but if you are in shortage of sample size, like you have 16 only that you can ask in your sample, then you must assume that your random variable x is a normal distribution, or the worst case is that it should be approximately normal, so you can conclude that the distribution of sample means is also normal. Okay, so now we can solve B. What is the probability that the mean time spent per customer is at least 3 minutes? So we have 16 customers. Remember, n is 16. And so if we want to solve the question, it's asking what's the probability that the mean or the sample mean of those 16 customers is at least 3 minutes. So bigger than or equal to 3 minutes. So this is the question. What is it? N is 16, and so we can get the mean of the sample means. This will be the same as the population mean, which is given here, 3.10. Of course, in minutes here. And the standard deviation, sigma x bar of the sample means, will be the population standard deviation divided by the square root of the sample size. Here the sample size is 16. And sigma is 0.40. So this will be 0.40, the population standard deviation, divided by the square root of the sample size, 16. And so if you do this, you'll get 0.40 divided by radical 16 is 4, and 0.40 over 4 is 0.10. So it's 10% of a minute. So this is in minutes. So it is 6 seconds, if you want in seconds. Now, to find this probability, let's put it in another color inside a box and go to the online calculator. But first, I want to highlight the mean and the standard deviation of our question. So let's highlight just the standard deviation of what it is without the calculation. Okay, so we go to the online calculator. Okay, so we put it here and let's write. So first we need to remember our mu is 3.10. Notice that here we want an area from a value. So we are still area from value. So the mean for us is 3.10. This is the mean of sample means, 3.10. And the standard deviation, I remember it was 0.10. Remember, I show you it's here. We just did it. It's here. Okay, so now we want what? Above 3. So still above, but you put here 3. And let's see what the answer is. 0.8413. And this is 84.13%, the probability. Okay, and as I told you, always look at the picture here, and when you solve by yourself a question, remember, take a screenshot showing all of this and send it to your professor. Okay, let's go to part C. So it says there is an 85% chance that the sample mean, that means the X bar, is less than how many minutes? So what they're asking is, if you take the distribution here of the sample means, now we assume that it's normal, so we can apply everything. So here is your mu X bar, which was 3.10. And remember, sigma was 0.10. Okay, and they want 85% chance that it's less than how many minutes? So you have that the probability that the sample mean is less than some value is equal to 85% or 0.85. So here they're giving you the area. So they're telling you that 85% is less than a value. And find this value. Okay, so the value is the one here. So this is what we need to find. This is, let's call it X bar, X0 bar. I'll do it in blue so it looks better. So this one here is X0 bar. This is what you want to find. So now you have the area and you want to, from the area, find a value. So let's see. Here we put value from an area. What is the area that we're given? 85%, so 0.85. The mean for us is 3.10. And the standard deviation, how much was the standard deviation? I remember it was, because we still have 16, of course, so the standard deviation we calculated here, remember? This one, 0.10. So we will put 0.10. This is the standard deviation of sample means. And you want the area below it to be 85%. Okay, so here you'll say this implies, and the answer is here. The value is here. So this means that X0 bar is 3.204. So this is minutes, of course. And you can see the graph here. Okay, so value from an area. Now, if you select a random sample of 64 customers, So now they're changing the sample size. Now n is no longer 16, it's 64. Okay, because n is 64, so you can say we can apply the central limit theorem immediately. And our x bar is going to be normal with mean mu x bar and standard deviation sigma x bar. So what is our mu x bar in this case? This is the same as mu, which we know already, it's 3.10. But what is our standard deviation? Our standard deviation is the population standard deviation divided by the square root of the sample size. Our sample size changed now, so it will be divided by radical 64. But our sigma, what was it? It was, now you want the population sigma. So this is our sigma now, 0.4 t minutes. So here you'll say 0.40 over radical 64, which is 0.40. Radical 64 is 8, and so this will be 5%, 0.05 minutes. So now this is your standard deviation and this is your mean for your normal distribution. Okay, so highlight them and just put them in the calculator. But now the question is what? It's the same actually. There is an 85% chance that the sample mean is less than how many minutes? So the probability that x bar is less than a value should be 0.85. And we need to find this x1 bar, let's call it, because we have used x0 bar above, so you don't mix them up. And it's the same exact picture here, except that the standard deviation is 0.05 instead of this one, the standard deviation. Let me just write it here. For this one, if we put here, the standard deviation here was 0.10. If you remember, this is sigma x bar. When we calculated it here, we got 0.10. This is when we had 16 customers. But now we have 64 customers, so the standard deviation of the sample means decreased because you're dividing by a bigger number. And so you got this. And all what you have to do now is find this x1 bar. So what I'll do is 85% again, same mean, but standard deviation changed. It became 0.05. And so, and we want the area below. Because see here, this is the one that we want. The x, this is the one that we're looking for. So we want the area below it to be 85%. We have the area, we want the value. So now calculate. So we get the answer here, 3.152. Okay, and the picture is there. So you'd say here 3.152. And so this is our answer. Okay, good. And the picture is here. 3.152. Below it is 85% of that the probability that our sample mean is less than 3.152 is equal to 85%. The area below it is 85%. Okay, so this finishes problem 2. Since it took some time, I'm going to solve one more question now. But as I told you, problem 3 is very similar to problems 1 and 2. So please send your professor the answer to this one. Just print it out and write on it and take a screenshot and send it to your professor. Okay? And now, please take a short break, and after 3 seconds I will start. So pause the video now. Okay, so now we have 3 questions. All of them are similar, but I'm going to choose one of them to solve. So how about I will solve problem number 6. The other 2 are very similar to it. So please send your answers send the answers to 4 and 5 to your professor to check if you did it correctly or not. Okay, so let's see this one, and pay good attention, please. You have to understand something in this type of question. It says, the restaurant in a large commercial building provides coffee for the occupants in the building. Fine. Okay, so we understood this. Now the restaurant has determined that the mean number of cups of coffee consumed in a day by all the occupants is 2 with a standard deviation of 0.6. So we need to write this down. But let's read the question just to see what it is asking. It says that a new tenant of the building intends to have a total of 125 new employees. So probably this will be our sample size. This will be the sample size. N is 125. Now the question is, let's highlight the question. What is the probability that the new employees will consume more than 240 cups per day? How about you try pausing the video and thinking about at least writing the given down. What is the given? And what is the random variable that we have? And what does the question ask us to do? At least write these and then unpause the video and see how I solve it. Okay, so I will start solving it now. So it says that the mean number of cups of coffee consumed in a day by all occupants is 2 cups of coffee. Of course, this means per occupant. So the mean is 2 cups of coffee. So you'd say 2 cups of coffee. Now, what is our random variable x? This is the number of coffee cups consumed by, coffee cups consumed by a customer. Consumed by a customer. Notice that I'm putting by one customer, like by a customer, because they are giving you the average per customer. So how much each one is drinking on average is 2 cups of coffee per day. And the standard deviation for this population is 0.6 cups of coffee, of course. I can just say cups and you understand it's about coffee, but let's just write it. Okay, so we know our random variable, we know the mean and standard deviation, but there is a problem. If you look carefully, have we read that this is a normal distribution? Did they tell us that the number of cups of coffee consumed in a day by people is normally distributed? No, they didn't say that. But they told us that we have a sample of 125 people. This is good because this is bigger than or equal to 30. So this means that whatever the distribution of x is, the fact that this is bigger than or equal to 30, you can apply the central limit theorem. So this should make you happy, because now the central limit theorem, what does it say? Why are you happy? It tells you that x bar follows approximately normal distribution. Approximately normal. Not only that it tells you that it's approximately normal, it also tells you that its mean is the same as the population mean, which is 2, and its standard deviation is the standard deviation of the population divided by the square root of the sample size. And so in this case it will be 0.6 divided by radical. Sample size is 125. And so if you do this on your calculator, let me do it on a calculator. So I want 0.6 over radical 125. Okay, so I will write it here, 0.05366. I'll put 7. So I'm taking it to 4 digits. Okay, you can take it to 2 or 3 digits if you want, but I want to be accurate with my answer. So that's why I take 4 digits. Okay, and so now you know the mean of the distribution of sample, the mean of the sample means, and you have the standard deviation of the sample means. Once you have these two, you can use the calculator, but before you use it, you need to know, okay, so, in the calculator, remember the online calculator, you have area from value or value from area. So we need to check which one are we solving here. Now, what are they asking? What is the probability that the new employees, the 125, will consume more than 240 cups per day? Okay, of course, this is not per person, but you need to change it to be per person. Okay, you can think about it this way. We have 125 people, and we want them to consume more than 240 cups per day. So we want them to drink 240 or more. So this means, on average, how much do we want each of them to drink? So we'll do, we have to divide 240 by the number of the employees, 125. This will tell us how much each of them should drink. So this is telling us that we have, we have 1.92. So this means that 1.92, this is what? Cups per person. We want this much of cups per person so that they will drink 240 or more. So now our question is, what is the probability that the average number of coffee per the sample, or the sample mean, is bigger than, so each one of them will drink more than 1.92 cups of coffee. This is where you have to be careful. You cannot put here, I think that if someone read the question quickly, you might think that you should put 240 here, but that will be wrong, because you have 125 people that you want them, all of them, to drink more than 240 cups. And your mean is per person. This is per customer or per person. So let's say per customer. So that's why you need to do bigger than, or if you put equal, it's okay, but they said more than, so put it strict. So now we have everything that we need. We have the mean, we have the mean here. We have the standard deviation of the sample means, and we want the probability that the sample mean is more than 1.92 cups per day. So you will go to here, and let's see what has changed. So now we want what? We have a value, and we want to find the probability, or the area. So area from a value. So you have the value and you want the area. And now, what is our mean? Let's just put it here so we can copy it easily. Now when it comes like this. So our mean here is 2. Our standard deviation is, I have to put it up a little bit, 0.0537. And what do we want? We want the probability above 192. So above, and here you'll put 1.92 and calculate. So this is giving us 0.9319. So let's see, is this good news for the coffee shop or not, or for the restaurant? Yes, it's good, because the probability that those 125 new employees that came to the building will consume, 1.92 is like almost like 2 cups. Okay, so the probability that they will consume 1.92 cups per day, each one of them, or the mean of this sample of 125, the probability that they will consume more than 1.92 cups is 93.19%, which is a very high probability. So this restaurant should be optimistic and looking forward to those new employees coming. Okay, so this is solved. I just feel that I need to at least in this one tell you how to start. The number of pages produced by a fax machine in a busy office is, this one is normally distributed from the beginning. So I think that maybe I should let you do it since it's normally distributed. But just I want you to understand something. The mean is 275 pages. The standard deviation is 75. So let's write it. First, what is X? This is, I'll highlight it, the number of pages produced by a fax machine in a busy office. So all of this is our random variable X. Let's just do it like this and say that, just write it here, please. X is the number of pages produced by a fax machine in a busy office. Is normally distributed. So this is good. So you can say that X follows a normal distribution. And the mean and standard deviation, of course, you put squared. You put the variance when you do this. Okay, and so here, what is mu? They're giving us that mu is 275 pages. And sigma, the standard deviation, is 75 pages. And what is the question? The question is, determine the probability that in 1 week, 5 days, okay, more than 1,500 faxes will be received. Okay, so here, let's think about it. We want 1,500 faxes during a week. You know, a working week means 5 days. You know, from Sunday until Thursday. Sunday, Monday, Tuesday, Wednesday, Thursday. Those are the working days. And then you have Friday and Saturday off. So those 5 days are the ones that you're working in, and you want to find the probability that during those 5 days, so our sample size here is 5 days if you want. And we want to receive more than, the probability that we receive more than 1,500 faxes. This is in the 5 days. So we want in 5 days receive 1,500 faxes or papers. Okay, but since it's a fax machine, you can say faxes. So per day, how many do you want? This means if you want in 5 days to receive 1,500, think about it, then every day you should receive approximately how much? You do 1,500 divided by 5 days, and so you'll get 300. So if you get 300 faxes received every day, then in 5 days you will get your 1,500. So the question is, what is the probability that our sample mean is, we want more than 300. You know why? Because X is per day. This is here the number that they gave you with mean and standard deviation. This was per 1 day. So each day the average is 275 and the standard deviation is 75 faxes. Okay, so here just to remind you, this is pages or faxes, and so you just write it here also. And so that's why we put 300 here and we don't put 1,500, because our sample is days, and you want on average for each day how many from these 5 days. What's the probability that on the sample mean of these 5 days will be more than 300? And let's use the online calculator, and we enter the given. So notice that in this case, there is something that because it's normally distributed, notice that normally distributed, what does it mean? It means that we can use the CLT. So not the CLT, I'm sorry again. So you can use the thing that is written next to the CLT. You know, if you want to consider it as part of the CLT, it's okay. Consider it as part of the CLT. So I don't keep on saying CLT sometimes and not CLT. The one with normal population when you start is not part of the CLT, but it's better to just put it with it and consider it as part of the theorem. So if we have a normal distribution, then it tells you that any n is fine, and you will get the distribution of sample means following a normal distribution. Exactly normal if you start with normal, and any n is okay. So let's go now to our question and finish this. So we use, what is mu x bar? This is the same as mu for this. So the mean is 275 pages or faxes. Let me say pages. And the standard deviation of the sample means is the standard deviation of the population over the square root of the sample size. And so remember, our standard deviation is 75 divided by the square root of n is 5 days. So this will give me 75 over radical 5. Let's find it. 75 over radical 5 is, so it's 33.54. You can stop here, but I'll put the 1. It's okay. It wouldn't hurt anyone to put this one. So highlight these two and solve the question. So let's use green to highlight. So this is my mean now for my sampling distribution of sample means, and this is my standard deviation. And just to make it look better, like this, 33 point this. So all what we have to do now is just to fill in the blank here. How much is it? Okay, so the online calculator now, we'll put it and we'll finish. So we want what? We have a value and we want the area. So area from a value. Okay, so the first one here. Now, yeah, I need to put the mean up so I can see it. Oh, or remember, the mean is 275. So we'll put 275. The standard deviation 33.541. So I'll put 33.541. And we want above, this is above 300. So more than 300. And let's calculate. So we're getting 0.228. 228, which is, so this is the answer, which is 22.80%. Okay, this is the probability. And look at the graph here. I just want to make you understand something. If you remember the lecture that was just on normal distribution before we did sampling distribution of sample means, we only need the mean and standard deviation, and then we know above, below, between. That's all fine. The only difference with the sampling distribution of sample means is just the standard deviation changes. Okay, so the standard deviation in this question was 75 pages. Yeah, you cannot put it there because you have a sample of 5 days. So you just have to divide the standard deviation by the square root of n, and then you put it here. And if you remember, it was 33.541. 33.541. And then the question is above 300. And I explained why it's above 300. Okay, make sure, because the question, if you put 1500, it will be wrong, because they're asking you, they want over the 5 days to receive 1500. So per day, it means that they want at least to receive 300. This way, in 5 days, they would receive at least 1500. Okay, so good. So we solved this question at the end. And now your job is to solve problem 5. Remember, this is your homework now. And there was another one, this one here, number 3 and number 5. Please download them now and work on them. And 5 is similar to both 4 and 6. And 3 is similar to 2 and 1. Okay, and last thing to say is thank you for watching. Please like this video if you feel that it helped you, and subscribe to my channel if you're not a subscriber yet. And if you want to get notified when I put new videos, please turn on the notification for this channel. Thank you very much for watching, and I'll see you in the next lecture.